Okay, so the questions that I'm going to go over are from the 4-1 to 4-2 quiz review. And I am going to start with number 10, and then I will ask my class if they have any other questions that they'd like me to go over. Okay, so number 10 says that we're going to sketch this polynomial function, and we're going to do it by finding the end behavior, the y-intercept, and the x-intercepts. If we need our calculator past that, then we'll go to our calculator, but we're going to start with just that information. Okay, so we'll start with end behavior. Remember, to do end behavior, this needs to be in standard form, and if I look at my exponents, 4, then 2, then none, it is in descending powers, so we're good on standard form. So from this, what is the degree? Yell it out. 4. It is that highest number. And then what is the leading coefficient? -1. Excellent. Now, from that information, the degree of 4, that is telling me this is an even. The leading coefficient, -1, is telling me this is negative. Anything even, we want to kind of think about a quadratic, a parabola. The end behavior is going to be the same for a parabola as it is for any evens. So where are my arrows going to point? Same direction or different directions? Same. Now, because this one's negative, are they going to be up, up, or down, down? Down, down. So I know the outside of this graph is going to be down, down. You know, it could look like a parabola, or maybe it could have like a crazy little shape in the middle. I don't know what the middle looks like yet, but I know that it is a down, down. So now we're going to write our, I'm going to just write it over here. We're going to write our end behavior with those symbols. Did I tell, I think you're the only class I might not have called them this yet. Did I call the symbols in here emojis? Did I say that in here? Okay. For whatever reason, I thought maybe I had forgotten to call them that in here. Yeah, so we're going to write our emojis. We're going to say something using symbols. We always, and this is written on the board behind my head, we always start with the left, then go to the right. When we write the end behavior, we do y values first, then x values. So we're going to start with the y values. What's my emoji that means y? F of x. What's the emoji that means like goes to? The arrow. And then on the left side, since I'm talking about the y, I'm thinking about up, down. Where is this going on the left? You guys told me both of them are down, right? So down, -infinity. And then we write as x, arrow. The x section of this is always the same, in the same order. We always go from left to right. Which x is left? Which x value? Which infinity? Sorry. Which infinity for the x? Negative. Okay. And then we write the right side. We will always start with our y values. So we use our emoji f of x. We use our emoji for is approaching. And on the right side, where is the graph going? Down. So -infinity. As, and then this will always be the same because it's the right side, which infinity is positive. Yeah. I'm just highlighting really fast. This is the only thing that changes every single time you write the end behavior. That's the only thing that changes. Everything else I wrote there for the end behavior is the same every single time. So we talk about memorizing. You memorize all of this. You only have to figure out what I highlighted. And that comes from that down, down in the graph. Okay? Questions before I go on past end behavior? Okay. So that was the first thing. So I know my graph, and I'm going to erase this as soon as I write it. So this is just me writing it so that people on the computer can see what I'm saying. But I know that when I'm done somewhere on my graph, the ends are going to go down. Okay, but I'm going to erase that because I don't know if that's where they are going to go down. All right, next. Y-intercept. We had that on our quiz today. How do we find the y-intercept every single time? Make x 0 cut. And when we're done, it will be an ordered pair. So in my equation, f of 0 equals negative 0 to the 4th plus 10 times 0 squared minus 9, I get negative 9. So we write my y-intercept as 0, negative 9. Okay. Does anybody have an idea of the highest number of x-intercepts there could possibly be for this equation? I'm sure I've said it, but we haven't been assessed on what I just asked. The highest number of x-intercepts, I'm just going to write it up here. And before I fill in the blank there, oh, there's a question right there. Before I fill in the blank there, just think about, like, for a quadratic, what's the highest number of x-intercepts for a quadratic? Do you have a question? Or are you going to say the answer? What's the highest number of x-intercepts for a parabola for a quadratic? 2. A parabola, yeah, for 2. How about for a line? What's the highest number of x-intercepts? X-axis, the highest number of x-intercepts is what? 1. Junie, what were you going to say? What do you think? For this one, it is 4. Does anybody know where she's getting 4 from? What do you think, Mike?
It's like for a quadratic, it'd be like squared, like the highest exponent on there.
And what does that highest exponent tell us?
Cross the x-axis.
It does, but it also tells us the degree. So the degree is the highest number of x-intercepts we could possibly have. Now, we could have less, because remember, with a parabola, I'm going to redraw this parabola picture. We can have less, because with the parabola, we could have a parabola that never crosses it. So we could have less. But the highest number of x-intercepts is the degree. So when we look at this question, Junie said we could have 4 x-intercepts. We might have 4 different answers or less. Okay? All right, x-intercepts. How do we find the x-intercepts? Make y 0. Okay, so I'm going to make y 0. That's going to be 0 equals negative x to the 4th plus 10x squared minus 9. Made y 0. Back in chapter 3, our previous chapter, we learned to find x-intercepts by complete the square, quadratic formula, square roots, and what's that 4th one? Factoring. Okay? For the most part, factoring is going to be the questions that I'm going to give you when we've got higher values until I teach you more things. So for now, if you can find the x-intercepts, it's going to be a factoring thing. Okay, this is not a quadratic, so we're going to go with factoring. So what is our first step of factoring? Yes, say it louder. Thank you. GCF, solve by factoring. We're going to look for the GCF. Is there a GCF? Yes, there is. -1. Now, -1 can always be the GCF if you want. But if it starts with a negative, to factor it with starting with a negative, it is a lot harder than to factor it if it starts with a positive. If it starts with a negative, it gets confusing about figuring out the signs. If it starts with a positive, then we can use what we learned before, saying, hey, if this is a plus sign in both of my parentheses, I'm going to have, I can't think. I'm going to have the same sign. What do I multiply together that makes x to the 4th? It's x squared and x squared. What can I multiply together that gives me a 9? 3 and 3? Or 1 and 9? Anybody want me to guess one of those? The 1 and 9? Let's guess the 1 and 9, okay? So we guess it, and then we check it, and we say, that's -9x squared. That's -1x squared. Do those add up together to give me -10x squared? Yes. So we have the correct one. I'm just erasing the check so I don't have to use space. Okay. Now, if this is not a power of 1, we check to see if we can go further. The check for, or the factoring for 2 terms, is it subtraction? Is this subtraction? Yes. Perfect squares. Is x squared a perfect square? Is 1 a perfect square? What times itself equals 1? So 1 times 1 is 1. 1 is a perfect square. So if it's that, then we have to do difference of squares factoring. Difference of squares. So my next step is going to be negative. And then I'm going to have 2 parentheses for this first one. X plus 1, x minus 1. Yes, Angie? Yeah. You need to... So take that thing, flip it like all the way the other direction. You know how to use it that way? Okay. All right. Same question with x squared minus 9. Is it subtraction? Is everything perfect squares? Yes. So that's going to become 2 parentheses, x plus 3, x minus 3. So it's going to factor difference of squares. Now, if we look at every single parenthesis, we see x to the first power. Well, we don't see the 1. But if you look at every parenthesis, we now have x to the first power. That means it can't go any further. We're done. We're done with factoring. Okay, after we factor, to solve by factoring is we set each factor equal to 0, and then we solve each factor. Close it all the way. I think, like, sorry, go that way all the way. Should just work. I don't know why it's not working. You can grab your phone and use it and just leave your phone back in here when you're done. Okay, sorry. Set each factor to 0. So I'm going to go through, do I need to set -1 to 0? Do I need to set -1 to 0? Is that going to give me what x equals? And that's what I'm trying to find. No. So that you don't need to do. But then I need to do x plus 1 equals 0, x minus 1 equals 0, x plus 3 equals 0, x minus 3 equals 0, and we need to find each x value. How many x values did I get? 4. And that's what we said the highest amount that we could get was. So I'm going to write all of my x-intercepts as ordered pairs, and I'm going to put them in order from least to greatest. So I've got -3, 0, -1, 0, 1, 0, 3, 0. Okay, any questions on finding the x-intercepts before we graph it? So the next thing I'm going to do is I'm going to plot all the x-intercepts and the y-intercept on the graph. I'm going to plot those on the graph. So if you are ahead of me, go ahead and put dots on the graph for all 5 of those points. Remember, what happens at the very ends? Where do the arrows go at the very ends? It's in here. I'm not showing it at the moment. Down, down. So on the very outside of the points, the very outside, I know that the graph is going to look like this. Everything else, you eventually will be able to do without a calculator. But we aren't there yet. So let's go type this into our graphing calculator and look at what the graph looks like. Connect these in a way. If we can find, if there's any more ordered pairs we can find from our table, we'll do that for accuracy. But let's type this into our graphing calculator. It'll probably take me longer than you, but I'm going to do it up here. If you have any graphing calculator issues, like, I don't know, if there's something wrong on your calculator, call me over so that I can help you. If you don't have a graphing calculator today, again, remember, you've got to have one, but you can use Desmos in the meantime. What do you think? It's kind of fun. Maybe I should have changed my scale when I drew it. Let me see. I'm going to find out what is the x value when y is -2, or what's the x value when y is not. I'm totally saying it backwards. What's the y value when x is -2? 15. And when x is +2, 15. That's why it's a little bit off the graph. That's all right. So I could either change the scale of my graph, but I'm a little bit lazy right now and don't want to. So maybe I'll just go up like 1, 2, 3, 4, 5, way up here. Kind of writing over my other work. So this is like an M. Kind of looks like an M. Questions on this? So your goal is to be able to do as much as you can before you pull out your calculator, because that's going to help you towards the end of this chapter. We're going to lose time. I don't know why. I talked very slow. So if you have any other questions, please ask. We'll have a quiz on Monday. You can do as little or as much as you need. Keep in mind the scores that you got the past 2 days on your daily quizzes.